what do you need to know about the metric or SI system? You need to know the base units. You need to just memorize those. Length is meters, mass is kilogram, not gram, time is seconds, and temperature is Kelvin. We'll talk about that later in the year. So the SI system, metric system, same thing. The other thing you need to know are prefixes, and there are several that I think you need to memorize. There are many more. There'll be a big table in your book, and they are kilo, deci, centi, milli, and micro. And micro, the symbol there is a mu. That's a Greek letter M. And they have a certain meaning, and you would apply the meaning, the value, to the root unit. So for example, 1 kilogram, kilo means 1,000, and so that would be 1,000 of that base unit, gram. Similarly, a millimeter would be 1,000th of a meter. Okay, and so you need to know those prefixes. Now let's do volume. Volume is based on the base unit of length, and so I'm going to make a little box that is 10 centimeters on all sides, and so it's a cube that's 10 centimeters in all direction. And so if I took 1 little cubic centimeter there, that's 1 cubic centimeter, that is a milliliter. And there are 1,000 of those little cubic centimeters in this box. And so this whole box is 1 liter. So you need to know this relationship, that a centimeter cubed is a milliliter. And then 1,000 milliliters is going to give you 1 liter. And you already have a good feel for what a liter is. You know, a 2-liter soda bottle. And so that is where the volume unit came from that we will use in chemistry. Now, let's talk about converting units. The way that we convert units is this. Always write the given. Now, I know that you might have learned a quicker method by sliding decimals and maybe using some boxes and something about King Henry and chocolate milk. I know you know how to do that, but I want you to follow this method. This is what we're going to use to convert things for the rest of our chemistry course. And so please get used to this method. So we write the given, and then the unit that we have goes opposite. So since centimeters is on the top, I want to put it on the bottom, and then the unit that I want, I'm going 2 meters, goes on the top. So when I multiply, what will happen to those centimeters? They'll cancel, top and bottom. Now here is the tricky part. What is the equivalent between meters and centimeters? What numbers can I put in there and make that true? Well, I can say that a centimeter is 100th of a meter, and so 100 of them is in 1 meter. So 1 meter is the equivalent of 100 centimeters. So the ratio that you put in there comes from an equality, something that is true. So if both sides are equal, the ratio of those two things is the equivalent of 1. When we multiply, those units cancel, and we're left with 0.752 centimeters. Sig figs do not change because those are exact numbers. All right, let's do another example. This time we're converting from kilograms to grams. I'm going to write the given, and then don't stop. Go ahead and write your fraction. Put the unit that you have opposite. It's on the top. I can make it like this if that makes it feel more like a fraction. I've got the unit opposite, so it will cancel, and then I'm going toward grams. Now, what is true about grams and kilograms? You know that the number is 1,000, and so what makes this true? Is it 1,000 grams equal 1 kilogram, or 1 gram equal 1,000 kilograms? Well, kilo means 1,000, and so 1 kilogram is 1,000 grams. So the 1,000 goes with the gram and the 1 with the kilogram. When we multiply, kilograms cancel, and we're left with 170 grams. And then you think about that. My unit got smaller, so my number of them got larger. Now let me show you one other fancy conversion. This is converting 2 units at once. And we can do this. Let's go ahead and write our given. Now watch how I write this given. We have milliliters per seconds. So seconds goes on the bottom. Can I convert that to liters per hour? Well, I can get milliliters to liters, and I can get seconds to hour because they're both time. It's just going to take me a couple steps. So I'm going to trade in my milliliters for liters. And honestly, this is how I set them up. I do all the units first. Saves you a lot of trouble in the end. And then I want to get rid of seconds. Do I know the relationship between seconds and hours? No, but I can do seconds and minutes, right? And then I can do minutes and hours. Okay, and so let's see, will my units cancel? I want to make sure I have my units in the right place before I put the numbers in there. So milliliters will cancel, and then seconds will cancel, and then minutes will cancel, and I will be left with liters per hour, which is great. That's what I was looking for right there. Now let's go back and throw some numbers in here that makes these relationships true. So I know that 1 liter is 1,000 milliliters. Remember the box, those little milliliters. 1,000 of them makes up a liter. And then you definitely know 60 seconds is in every minute and 60 minutes in an hour. And so all you have to do, those units will cancel. Go to the calculator, 5.2 divided by 1,000 times 60 times 60, and you will get 19 liters per hour. And sig fig wise, we want to start with what we started with. So I hope these little tricks will help you converting units. And here's my pro tip. Practice writing equivalents. So for example, centimeters and meters. What does centi mean? Centi means 100th, and so 1 centimeter is 100th of a meter. Milliliter, milli means 1,000th, so 1 milliliter is 1,000th of a liter. If you can write equivalents or equalities, those are your ratios. You can do metric conversions in chemistry. I believe in you.